G'day guys. Yeah, I'm just upgrading a GPX-7000 and very interestingly, I thought most of the part numbers were left on these, but I'm finding that in between the boards, on one of the boards, uh, basically near the transmit stage, and there's a current shunt or current measuring very low ohm metallized resistor, laser cut, so it has to be pretty accurate. I think for its measurement, there's a couple of MOSFETs there, and they haven't got the top part of the chip with numbers. So I've just been using the little device, the little digital microscope on those chips, and as we were talking about AD797s in the last video, well, I was, about some I think are and some I think are not, in my opinion, and I don't know for sure. Okay, these, I just did some static measurements on these, and they actually seem to be AD797s in an area that would need very high accuracy, relatively low drift and low noise. This could be what they are, and I can't take that over to the camera, but these devices here, you see that thing there, that's very well, basically pretty bundy, low value resistor. Might be 0.01 of an ohm or something. And these devices, you can see at the top here, there's no numbers on them except at the bottom. It's got numbers, and they don't look like any ICs I've ever seen, and they're not serial numbers as in different ones or anything. Could be batch numbers or something, but there's nothing on the top of those. It looks like it's been chemically etched off, not ground off. I just don't know, but they do have some numbering on them, but it doesn't make any sense. But I did a bit of an experiment with testing these, and they are AD797s. Even here, this chip here, that drives all the MOSFETs, the pre-drivers and the actual setup for the transmit stage, which is on the other side of the board, where it's got those two power FETs there, and these polypropylene, I think they're polypropylene capacitors. What else is interesting? Yeah, so there's a lot of drivers in here. FDS 27 something or other, I can't remember the numbers, 2672s, that drive the gate to these FETs, because with the 7000, it needs very stable transmit current, and if it wobbles, the receive signal will also get noise in it. So they use these rather large MOSFETs. They've got a ridiculous current rating on them, but the gate capacitance is so high that to drive them, they've got to use other eight-legged MOSFETs to drive the gates of these things. So it's a pretty critical setup there, and thus that's probably why on this side here they're using those AD797s. I'm pretty sure they are, because they check out. I measured all the biasing for offset adjustment and that, and it all corresponds with the right values for that. So yeah, that's how it monitors its current there, and obviously if anything goes skew-f, these devices here, either one or both, keep track of things and try and keep things level, or compensate, or whatever it does. So yeah, that's the back part. Not a lot of people will pull these apart and get in on this part of the board, but that's basically what's in there. And on the other board, you can see where the microprocessor is on the other side here. There is lots and lots of tiny capacitors and big capacitors, of course, trying to keep the noise out and bypass a lot of functions of that processor. So it's not a bad detector the way it's designed. You know, I used to do RF work, and yeah, it's very much like someone who was in the radio trades designed the board by the look of it. They've done really good separate ground planes, lots and lots of, you know, when we used to do transmitters and receivers, we used to do all this through plating on the edge here. You can see those little dots that joins, you know, a ground plane on the bottom to the top or whatever, or with one in the middle, just so the whole thing doesn't radiate. It's a very clean design. So yeah, that's how they work. The only trouble you ever have with these, possibly, because these are these plastic standoffs with the other board clips on. If they, I don't know if they come loose or whatever, maybe they grow their plastic, you know, they get hot, they get soft. You can get bad connections where the other part of this pushes in. So if you got the two boards and you lose, it comes like, you know, coil fault or can't find the coil or whatever. This is the part of the data from the dongle in the cable plug, goes through the board. It's got some other, you know, we'll call them interceptor code interceptor chips, and they just read the code coming out the dongle and ends up on this board, goes into the micro for I think a 1 or a 10k resistor. But yeah, these plugs, if there's any they separate a little bit or anything, you might lose. First thing I've known, I found it myself on a detector. It wouldn't you know, register that there was a coil connected, and I squashed the boards together like the two boards and just away it went. So pulled it apart, cleaned it up with isopropyl alcohol, and put it back together and put a couple of rubber bands around it to hold it really tight. That's a good way of doing it. You could hot melt glue it if you wanted to on the side of the connector, but just put a couple of rubber bands around it, hold the boards tight so you don't get any you know, weird stuff happening. So that's a 7, and yeah, just wanted to point that out because you know, those AD797s, even though they're a chip out of the 80s, they are old. They are so old. They keep popping up everywhere. So you can't escape them because of the low noise figure. There are other chips around that come close. There is a better chip actually, if anyone can ever get it to work. Is the old LT1028 made by Linear Technology, which was taken over by Analog Devices. But anyway, they're still out there. But they're not gain stable in a non-inverting configuration. You've got to run them in inverting configuration, and they are sort of stable. So yeah, I tried making up some adapter boards with those in there, and I said, oh, come on, I can make it work. I was playing around with the compensation capacitor pin and heavily compensate it. No, it doesn't want to work. The trouble with these detectors, especially the older SDs and GPXs, is that the bias that is supplied to the IC when it goes into transmit mode, it basically more or less open circuits the input pin on the chip, so it's got no bias current. So they put a BF908 and a 1K resistor that switches in. It's a dual gate MOSFET, which are no longer made, by the way. Watch out for that. That basically switches on when it's in transmit, because the transmit coil's obviously disconnected from the receiver. So the poor thing's there floating, going, oh, I've got no bias current. I don't know what to do. I'm going to just oscillate and carry on. And basically you get a really slow settling time when the receiver comes back on. And, if you're sampling very close to that point, you're going to get a lot of noise in the detector. So, it's all good fun. But there's a lot of other devices with that bias change. They don't like it, and they basically will putting it nicely, throw a bit of a wobbly. So we have to be very careful on what ICs that we use. There's some really good instrumentation amplifiers out there, which are low noise and everything, but they're slugs. They've got no speed, and you'll lose all your small signals or your signal response. It'll die off, and then you go for high-speed ones they've got out there, and they're damn noisy. You can't win. So it's probably better to make a hybrid. I've been making hybrids for a little while, and even those, with what's out there, they're so damn expensive. Like, I had a look at one-off prices of just the AD797s on DigiKey and Mouse, and they're up around about $30 Australian dollars each. It's a lot of money for an IC. And that's what I was saying with the NE5534s, which are a noisier equivalent. No, I'm not going to say they're equivalent, because they aren't. They don't have the frequency response. I think the AD797s will have a 3 dB cutoff point at about 110 megahertz or something. And NE5534s put out at about maybe 15 megahertz. So as it goes down into normal operating frequencies, your performance degrades because it just doesn't have the high frequency response. If you're looking at hundreds of kilohertz, then you've got something actually that cuts out at 15 megahertz. It'll have an actual impact on the slew rate, how quick it can acquire a signal and make some sense out of it and amplify it. Where you got something running at 110 megahertz, will basically work really, really well at the lower frequencies. Sometimes it can be overkill, and you start getting what we call leading edge, peaking, and also when it turns off, it can actually peak downwards. So then you've got to get all your capacitors right to even that out. Then that affects the operation of the whole thing, that you start filtering out small signals. It's damn complicated, so it's all good fun. But anyway, the 7000s, we've been getting a few 7000s through, people wanting the new high intensity, faster refresh rate screens, which work really well. Done a few of those. And just doing the mods on the 7000, get the noise out of the system. Basically makes it a lot quieter, and because it's quieter, it actually picks up depth and sensitivity. But and also the same thing applies with the 6000s. You're trying to get the noise out of the system. I think I think it might have been on Detectormods on Facebook. There's a picture there where it showed where 6000s had been, and someone following with a 4500 found all the gold they missed. It was quite amazing, because they burble, and the thing is that a lot of the people detecting with the sixes on particular ground, they've told me, so this is hearsay, right, that they have to lift the coil off the ground a substantial amount, keep the noise out the system, and then they're leaving gold in the ground. So I don't know. So anyway, I'm still expecting this new MindLab detector to come out shortly, even though people in MindLab will say, oh no, but yeah, the worst kept secret ever, in my opinion. I really do expect something interesting to come out. It's going to be a lot more cost. Someone told me that there's $1,000 cashback or something. Someone's giving $1,000 cashback on 7s or 6s or 7s and 6s. Probably, if that is true, which I just say it's hearsay, maybe you have to go to a shop and ask what the deal is. That would just say that they're trying to clear stock to try to bring in the new model. Okay, that is my opinion. I don't know for sure. So, check with your local shop and see if that's the deal. Yeah, I don't know. But anyway, this is only about those chips on that 7000 board. But yeah, just thought I'd point it out because we've got no numbers on them. So everything else has numbers except that big black module that if ever fails, you'll die a painful death, because you can't buy it as a separate part, so I am told. And that came from Minelab themselves, that you have to buy the boards. You can't buy one board, you've got to buy both. So even if the other board isn't stuffed, you've got to buy it as well. So, yeah, I could say something, but I won't. I'll leave it to your imagination what my thoughts are. Anyway, back into it. I've got to get these detectors done. I just did. This is only going to be a short one, pointing that out just so anybody who has unstable transmit waveforms could look in that area there on their 7000 if you're technically competent. Also, you've got to heat the boards up too. You can't just go in there and unsolder those things. The way they're ground planed, all the heat goes through the copper ground planes. It just spreads away. You can't get them up to temperature. You'll cause damage. You've got to preheat the boards. And that's why I bought this little preheater here. Well, actually, you can actually solder boards on it if you want. Gets up pretty hot if you want it. It's all programmable. But I'll tell you what, makes a ripper coffee warmer. So you turn it on and leave your coffee there. It doesn't go cold. Good secondary use for that. So yeah, digital coffee warmer. I set it at 100 degrees Celsius and leave the cup there, and it doesn't go cold. So as a side benefit, I wonder if I have to pay fringe benefits tax on that. But well, you know what governments are like. Yeah. Anyway, that is where we're at to now with doing 6s and 7s, and I've still got tons and tons of others to do. But yeah, Chari's there building boards for me at the moment. She probably can't hear me. Look. There she is. Listening to stuff and doing boards. Yeah. Okay, but not disturb her. She'll stop work. Okay, catch us, guys.